Hi, everyone. Today we're going to be baking a fresh Anchor policy bundle from scratch using two of my favorite rules that help really get your organization off the ground in terms of taking a first step in securing your software supply chain using policy. So policy is really great because it can take enforcement action in your CI pipeline. So it can enforce starting at source code. So if we generate a source code scan, we see something is violating policy, we could go ahead and fail that. If we detect it in CI when the image is built, we can also fail there. If we detect it before it hits runtime, so we could do that too using Kubernetes admission controller. All sorts of places you can take enforcement action. If not, all of those places, you can pick one or two. Okay, so let's start. Let's call this our software supply chain bundle. Oops, forgot the P. And then we'll say beginner friendly. And what we're going to do is just create two checks, right? Super low bar. So these are checks that anyone can do, but they're very effective. So let's start with vulnerabilities. Let's add a check for vulnerabilities. Now, there's a lot of data that's gathered from containers in terms of vulnerability. A lot of people call it vulnerability sprawl when dealing with CVEs and containers, right? Simply because there's just so many. Anchor provides a pretty good way to manage that though. So here we could set a rule. And what I'm going to say is anything that's greater than or equal to a critical and has a CVSS base score higher than an 8, an exploitability score higher than an 8. Again, the way I got here, just started editing this default policy that was listed on the landing page after I created my bundle. Okay, selected vulnerabilities gate, selected the package trigger. Now I'm here, all right? This is home base. Now, impact score, and I'm gonna say if a fix is available. That's super important, and I'm gonna get rid of the rest just to simplify things. That's super important though, because I'm only gonna really, punish my developers if a fix is available for that piece of software. If they have a fix available and they still want to say, yeah, we know it's a critical package and it violates all this criteria, and there's a fix available, but we can't make the patch because it's just such a critical package for our application to run, that's fine. We have an allow list function, and there's a video on that. So go to YouTube, look up Anchor Enterprise allow list that shows you how to do that. And we're going to stop. So this is saying anything that's greater than or equal to 8, right, across all these criteria, and it's a critical, please stop it. So we'll call this our vuln policy, just so we don't get confused. Check that out. And then that's being mapped to our container images. We can also add this check against source code. So we could say vuln policy from source. So if you want it applied to source code, you'll need to create another policy, and it will need to be under the source repo tag there. So you could go vulnerabilities, a little bit more straightforward here. Let's do the same thing just for parity. Anything that's greater than critical. And we said 8s. I'm from Los Angeles, 8, the infamous Kobe Bryant. And we'll say true, right? We don't really want to punish our developers heavy off the bat and make them answer the call for every single vulnerability ever created in the history of man. So we'll do that. And what's really critical here is you see that this is being used by no mappings for our last one that we created. So we'll fix that here. So then we'll create another policy for malware against our images. So we'll call this the malware image check. Go ahead and hit OK. And then we'll scroll down the gate. You can see we're getting kind of familiar with these gates. And we'll say if we scan it and it detects malware, that's what it's saying when it's saying scans, we're going to go ahead and flag it. So now that we have these policies created, what we need to do is map them. And so what mappings does is it accurately adds them to whatever artifact is being scanned. So here we have the policies, we have the vuln policy here, but we do not have our malware image check. So we'll go ahead and add that. And as you saw, you can kind of map this to whatever registry if you want to apply different checks to different registries, different repos, or maybe even a specific application tag, you could. For default vuln policy source mapping, we'll call this vuln from source. And then we'll wildcard those. Those apply to everyone. Okay, so there we go. That's our mapping. So we added one vulnerability check for our source code repo. And we added another vulnerability check just for parity against images. And then we also added our malware image check, right? So we could come in and take a look at how this looks. So the next thing we would have to do if we wanted to use this policy actively in this account, we would have to select activate right here. And there's another video that shows you if you want to do this all using Anchore CTL and using the API, you could totally do that. But what's really important here is that it's only applying to the context of this admin account when you hit activate policy. It's not applying to these other accounts. Okay, so let's go look at a source code repo. Let's go look at this. Open up this. See what our policy compliance says. We passed, right? Which is good. Take a look at our vulnerabilities. So you can see it's detecting criticals, but there's no fix available, right? So we're not going to go ahead and fail it, right? We're going to continue on. Then let's see how our container image stacks up. So let's go there. Let's check out a container image. So we passed this, right? So if we look at our vulnerabilities, we have 40 criticals, but none of them really meet that criteria that we set. Maybe this is a bad image to use because there's just so many criticals. Let's take a look at maybe something heavily consumed like Nginx, right? This passes, we detect vulnerabilities, we have 3 criticals, there is a fix available, and you're like, hey, wait, there's a fix available. Why aren't my developers fixing it? Well, it's a critical and it doesn't meet the CVSS criteria, right? So if we wanted to fix that, all you would have to do if you said, yeah, I don't know, that's a little bit too lenient for me, or a little bit, too lenient. All you would have to do is come back and tailor this up by hitting edit. So you could say, you know what, I've had enough of this. If it's a critical and there's a fix available, then I'm going to fail it, right? So I'll hit apply and we'll just reanalyze, or reanalyze is the wrong word here. We'll just take another look at that, right? Because it's not reanalyzing. It's just giving you a fresh policy evaluation. It doesn't have to reanalyze. So once we take away the exploitability score of it being a high exploit score, high impact score, then we start flagging for more stuff. And now you see that it generated that stop action. So it kind of shows the dynamic nature of the policies, but also 2 really good checks that I would use to get started. One, CVSS thresholds, right? Those are really powerful. Start implementing by establishing your threshold for vulnerabilities in your Anchore policy. 2, malware, right? So you should never have vulnerabilities that violate your organization's compliance threshold, and you should never have malware in your software supply chain. I think those are pretty basic. I hope you found this video useful. Please like and subscribe.